Konstantin, and we're talking something about coupling Raku with Ethereum framework, Ethereum blockchain. I'm very sorry, but my laptop, my Linux on my laptop cannot see the external display, and I would presentate under a macOS, and there is no Docker, there is no any practice. I would try to show you how to practical work with blockchains, how to practical works with Ethereum, but it will be just presentation, and I would like to explain everything better, but with no practice. Sorry, that's my... Okay, let's start. A few words about Ethereum. What is it? And some terms, some concepts. First of all, Ethereum, it's a distributed network, and like in every network, it has a nodes. What is a node? Node on Ethereum or node on any blockchain, it's a, for example, server, or maybe it's a laptop, and the software that's driven the node. We say that software on a node, it's a client. In Ethereum, there are a few clients. For example, its official client. The client name has a name Geth, official client by Ethereum Foundation. And there is some opposite clients, not they have war with official client, opposites like another communities, another developers, or something other. I using the Parity client. Parity is an organization that's just developing some opposite clients for Ethereum. Also, client is a software that encapsulates virtual machine itself. What it means? When you working with blockchain, when you have deal with blockchain, you have a deal with a binary ledger on a lower level, and to communicate with this ledger, you should have a virtual machine that fetching binary data or pushing binary data to ledger. So every node, in a summary, every node running client software, and this software encapsulates virtual machine itself to deal with blockchain. Okay, some slides. Oh, it's slides shows that terms of that I talked about. Okay, it's something from a node. Client, yes, I said it all. Client, node with a client, and party is a client with a simple settings. About the virtual machine, of course. Oh, another thing. It's what's about the consensus on a blockchain network. When we're talking about blockchain, we are thinking that there is a network, and the nodes in the network storing data decentralized. What it means? Every node could emit data, and every node could emit transactions. And all nodes should have an algorithm, should have a consensus to store data or not to store data. There are different algorithms, but in the stock, in a private network that I'm talking about, we use a proof of authority algorithm. What it means? It means in your network you should say this node or this node is authority, and only this and only authority nodes could sign transaction and could say, okay, your transaction is okay, and your transaction would be declined. Okay, that's enough about algorithms. Okay, and what's about Raku? No problem. We have a unit. We have a specific unit, the package. I mean, that has name net Ethereum. This unit, I contribute this unit. It was ported from Perl 5. The Perl 5 ecosystem has the same unit. The author of the Perl 5 unit also from Russia, but the Perl 5 unit, net Ethereum, Perl 5 package, net Ethereum, does not maintain anymore. But in opposite, in Raku, I'm still working on this, and maybe have some fixes, maybe it has some bugs, but I think it would be fixed in the future. This unit has functionality to querying client on your node via RPC. It's very simple: JSON data for requests, JSON data for responses. Just parse it and do with it something you need. Communicates. Okay. The special thing is about about the Ethereum special thing. I would like to speak about the smart contracts. It's very important because blockchain Ethereum does not store only binary data itself. Some binary data is a smart contract data that could be executed on virtual machine. For example, you could create a smart contract with methods, with global variables, with constructors and destructors, push it to blockchain as a binary, and knowing its address, node can fetch it back and execute on virtual machine. That's very important things. And smart contracts have been compiled by a Solidity compiler. It's a special compiler for Ethereum network framework. About application level, I have said something about this before, but on a low level, we have a binary ledger, then RPC client, then adapter, net Ethereum as adapter between client and high-level Raku application. And what we need to create the application with Raku to store data on blockchain or to fetch data, just high level with calls to net Ethereum. Here are some issues, known issues of net Ethereum. Okay, it's problems with UTF. I found out it a day before this workshop. When you're pushing UTF texts or UTF strings, some data is missed. Trying to fix it now. The next problem is that we're using HTTP user agent package that not provides keep alive connections, and that's very, very bad, because when you running tests, net Ethereum tests, that's about 1,000 tests, and when every test make a connection to the client and then freeze the socket stays for a while in your system, and if 1,000 tests with 1,000 sockets, you have limitations on your host, and sometimes tests fail it, but not due to the problems with tests. That's problems with the sockets. Keep alive connections resolves this problem, but this feature should be implemented in user agent. User agent is maintained by Jonathan Stowe, and we dealing with how to figure out how to create the keep alive connections live in this model. The next thing is the IPC support. Unix sockets is very must-have feature in Raku, but it still do not apply. Raku still has a native module on it, native package. As far as I know, there is a grant proposal for a Unix socket, but they are not still implemented. No matter, because we can use native calls or inline Perl 5, like with for example, IO socket Unix. And the other issue is it's caused by initial implementation on Perl 5 model where I was porting, and my porting techniques, because it was about 2 years ago, and I think everyone who looking on source code that was written in the past. Oh, what is it? Okay, but I'm still working on this, still contributing this, and think I will do some kind of refactoring in the future. Okay, it's Docker. Here should be a presentation on a practical part, but sorry. Okay, Docker is a great start, quick start feature with blockchains, because we have on the first link there is a direct link to the Docker image. It could be pulled from the registry, run on your server, on your laptop, and inside this container there is everything that provides functionality of a blockchain. There is all packages, there is helper repositories, it's the second and the third link, smart contracts example, smart contracts builders, it's scripts, helper scripts to create binaries from a source smart contract codes, and the Ethereum local network, that's a repository that contains helper scripts to run network on your server with one click. Okay, for example, there is a few scripts to run, to check, and to attach to a node. Sorry, but I don't have ability to show it in real life, but if you are interested, I will check. I will show it on my laptop after the presentation. You're welcome. Okay, the second part of my talk, it's about how to create a minimalistic Raku unit, minimalistic Raku package to deal with Ethereum. Okay, as I say before, we have a client, we have a net Ethereum. Net Ethereum is available from Raku ecosystem via dev, and on the top of pyramid we have a Raku application. That's not good, but in this application also there is a minimalistic module, minimalistic unit. Okay, like on this on this picture, minimalistic means that nothing on the shelf. Okay, I think it could be passed because it needed the live show on a console. And the next, we need a few. Okay, if we want to store something in Ledger, in Ethereum, we need two basic methods: reader and writer. Here is prototypes, and the thing we should know about these prototypes is that arguments, for example, we need to push the method name. Method name, it's a string and the name of the function of the smart contract. It's like something like a bridge between the Raku method and smart contract method. And the data, it's a simple hash with arguments to the smart contract function. Read returns cool because we're reading integers, booleans, and strings. Nothing else, because types storing on blockchain are defined by a smart contract typing language. I mean, smart contracts wrote with Solidity language, and their type system very limited type system. And in the write method also we have a blocking flag. This method could be non-block or block due to this flag wait tx, because when we're writing, we could wait where transaction would be mined, would be stored, would be signed in blockchain. Of course, under the hood of these methods, there are net Ethereum methods, such as contract calls and transaction and something other. In our model should be, of course, private methods I talked about before, and helpers and public methods that we need to implement to make our model more complicated. Of course, public methods is set data, get data. On an example, I have a smart contract with only two functions, setter and getter, and there will be a global variable that one method getting the value of variable and getter setting their value. And the helpers is extensions like we would like to check if node is active, blockchain network started, if we have a contract address inside our object, initialize methods is combined is node active and send contract, and read integer is just have a few conditions to check that the value from the blockchain is valid, because when we're dealing with JSON, we have maybe got some values that's not integers, maybe get some waste or something else, garbage. Yeah. And I propose to override constructor because we need. It may be useful to create net Ethereum object inside the constructor, but it's not problem because we have initialized helper, and this could be done there. No need to override constructor, but in my example, constructor was overridden. Sorry, but I have no ability to show it on a real code. Okay, that's all about minimalistic Raku model, and then also, and the next step is to create the application itself. I have an example with two applications. It's a console application, just a simple app running from console with a few command line arguments. First argument is a transaction hash, and the next argument is a value to store on blockchain. And the basic guideline of the application is grab arguments from command line, create minimalistic model object that we was developed on the previous step, initialize that model, and then set or get value. It depends on if the if the value to set is going through the command line. That's the algorithm of console application. And the web application is more interesting. Okay, it's a diagram how the console application works. Yeah, check value. If define set it, get value. Okay. And the web application is more interesting because we're using CRO services, CRO HTTP service, and they're, how to say it, it's something interesting because it's in browser, it's a post method, get method, working quite fast. I think only I should say about the web application, it's the post request is very difficult to Google how it works and how it should be implemented in the CRO documentation. I just find out how to implement it via the tests of CRO HTTP server, and if you have a deal with a CRO, maybe it will be useful for you. Okay, that's about the application. the next step. Okay, the last slides about the. I would like to talk that in example of this, in the examples that would I show you, but not. I would talk about the simple things like a store number in blockchain or fetch number from blockchain. But the real interesting thing is to store data like text, like maybe you have a distributed databases when something data is tamper-proof, some data is sensitive for stalling or corrupting, falsifying, and in this case, this data could be pushed into blockchain. And for example, also developing the content management system with a hybrid data storing model when some data, for example, ratings, votings, or something useful to something tamper-proofed are storing on blockchain, and other data like a content, like a pages, templates, and something other storing on regular databases. That's CMS called fakes. Yeah. Okay. Talk essentials on this link. I have a special repository for it. You can find out that source codes for the smart contract that I'm talking about in this talk. Also, there are a few documents like manuals or tutorials there, source code of applications, console applications, and web application, and also the source code of the minimalistic model. Also, I would like to invite if anyone interested in development, on the blockchain development, not Ethereum development, or something else, I welcome you. There is a links for repositories. They are free, they are open. You could take part in this work. Okay, and that is the last slide. I think my presentation. Yeah, I got it. Maybe you have any questions, and also I have sorry for I have now the practical part. But if you're still interested, I could try to show you on my laptop if you have questions about the practical part. You're welcome.
Why did you do this?
Why?
Why use blockchain?
Okay, the first thing is I have a clone of the content management system on Perl 5, and this content management system is used by a few sites. We have public sites. They were developed for some companies. We have customers on the site, and there are a few services. Data that using data with sensitive for falsifying or for stalling, could be stalling or corruption. And in this case, we decided to store in blockchain because, for example, when we have a important vote or important rating system, we could not store any vote and any element in vote data or any element in rating system. And how to prove that data in our database, in our regular database, is compactive and has no falsifying. And in this case, when we're using blockchain, we could say, okay, everything in blockchain is one block is have a reference to previous block or a second block, and there is no any attempt to falsify it. Of course, it's also is secured because the private keys on every site, and that's a proof for our customers, for our visitors that we are not falsifying any voting and any ratings. It's the first part. And the second part, in that content management system, we decided to move administrative section where you could update your data on your site from one server to another secure server. That's very great because anyone from public network, from internet, could not access this part. But database is distributed via two servers. We have a blockchain. Its main feature that when we modifying something on one node, it would be directly modified on another node. So we don't need replication, we don't need tunneling between databases, just a Docker on one server and Docker on two servers, and the data syncing automatically after updating. And that's a great feature because when site is under attacks and has DOS attacks, it's not matter. Nothing could be stolen, nothing could be corrupted. That's why. Okay, thank you.